All right. Okay. Well, happy Friday, everybody. And is anyone here participating in Data Fest? All right. Two of you? All right. Well, maybe the rest of you, maybe in a future year, you can participate. Well, but good luck at Data Fest. I'll probably stop in a little bit and see you guys there. I guess for the rest of you, well, after this class, you'll certainly have the skills and the tools necessary to, have fun, at least at Data Fest, and really, you might be like, oh, I don't know all this technical stuff. You don't need to know a bunch of technical stuff. It's really about exploring the data, and so. They always get some kind of interesting, complicated data set, and there are going to be so many different aspects that you can explore, and you can chop it up in different ways. You can ask different questions, and there's always something neat. Anyway, in today's lecture, I wanted to talk, just show you some applications of pivoting data. Because on Wednesday, I introduced this idea of pivoting data, but it was kind of this very here's a thing, and this is what happens when you pivot. And you can pivot longer and you can pivot wider. But I don't know if I made it clear as far as why you would want to pivot data or when it would be useful and things like that. So I want to show you a couple examples. I have just kind of a general example using the Gapminder data, and then I've got a couple of other examples coming from the textbook where we're just looking at some homework exercises, but they are, in my opinion, good applications of pivoting data. Everybody should be in a group for their final project by now, so you either established a group on your own or I emailed you and said you are now part of this group, okay? And what you should be working on now is just searching the internet or wherever for an interesting set of data, okay? An interesting and a reliable set of data is going to be the key. So you want to make sure the data that you get from whatever online source is reliable. Again, check for things like internal consistency and validity, and just, if there's external sources that you can kind of cross-reference, that's great. And then just ask yourself if you understand what each of these variables mean. There's I just thought of another example. I think there's a Spotify data set or something where they took songs, and the songs get rated on something like danceability and I don't know, these different kind of energy or things like that. They have these different kind of ratings, and the group that proposed using this thing, I just said, hey, what does it mean for a song to have a danceability rating of 0.9 versus a danceability rating of 0.6 or a danceability rating of 0.3? And they said, well, it means it's more danceable. And I said, well, what does that mean? And then, nobody could really answer, right? And I just said, well, here's a song. And I just kind of picked two arbitrary songs from the list. And I said, one of these has a danceability rating of 0.9 and the other one has a danceability rating of 0.3. Can you tell which one's which? And it was split. And it was just kind of they felt like they were just randomly guessing which one had a higher or lower danceability rating, which to me meant we didn't really understand what this variable encompassed. So, you just want to watch out for things like that. If there are variables in your data set and you don't understand what they are, that doesn't eliminate the data set. It just means I don't want you to use that particular variable. And so, I guess once you eliminate all of the variables that you don't understand, are there still enough variables left in your data set for you to do a meaningful and interesting analysis? And anyway, these are the kinds of things. So hopefully you have at least a meeting scheduled with your teammates. You have the meeting notes. I want you to document your meetings, and I know that's like annoying, but I do think it helps keep members accountable, because I don't know, I imagine, especially with you being here at UCLA, I imagine at some point in high school you were part of a group project, and then like you carried the weight of your group on your back, and maybe not everybody contributed equally, and so my hope is that by having these meeting notes, and part of the meeting notes is everybody, members get assigned some kind of task. My hope is that helps keep the groups accountable. Of course, it's dealing with people is always a little bit of a challenge, but that's that. And then if you have somebody in your group who's willing to be team leader, I do find that having a designated person kind of be the point person for assigning tasks and following up does help. And that might be a little bit of extra work for the team leader, but I do think it's worth considering. Okay, so anyway, let's take a look at pivoting data. And so we're gonna start by looking at the Gapminder data set. And so if you remember, the Gapminder data set has these numbers on life expectancy and GDP per capita and population, and it's for like this country at this moment in time. And as much as we appreciate the Gapminder data set, we also do have to keep in mind that some of these are inferred, or just at least our best guesses for what they are, especially because borders and countries have changed. And so the example that I use is we have the country of Germany today. If you go back 40 years, was split between West Germany and East Germany, and those were two separate countries. But in our Gapminder data set, it's just represented as Germany, and doesnand kind of have that historical, it doesn't have the changes to countries and things like that, and that's going to be for lots of other countries that have kind of changed borders and things like that. But those shortcomings aside, it is still still useful for us to look at. And in our example that we're going to look at today, we're just going to look at three countries. We're just going to look at basically countries in North America: Canada, United States, and Mexico. But this is what we have. And well, right now our data is kind of in long format, but we could argue that we could rearrange some of these things, even further. Basically, each row is an observation. Each column represents variables, okay? And each row is identified by the country in a specific year, okay? So we have, Afghanistan 1952, Afghanistan 1957. And we need these two columns, both the country and the year, to properly identify the row, okay? If I only gave you one of those columns, like country only, that will not properly identify the row, or year only, obviously, that won't identify the row. You need both country and year to properly identify the row. Okay, but here I'm going to just filter to the countries United States, Canada, and Mexico. And then, and in this plot, I'm going to put year along the x-axis. So in my, so what I've done is I filtered it, okay, and then I'm going to just pipe that filtered data directly into ggplot, okay, and in ggplot we're going to map the year along the x-axis, and then along the y-axis we'll put life expectancy, and then we're going to color our dots and lines based on the country, okay? And so I'm going to do point and line, and this will kind of connect, put dots and connect them, and I give it the title life expectancy over time. And so what we see is that, between 1952 and 2007, life expectancy at all of our countries have increased. We've seen dramatic increases in life expectancy for Mexico. Canada has also improved, and the United States also improved, but not as much as life expectancy improved in Canada. Okay, so that's what we see here. Similarly, we can also plot GDP per capita. Okay, so we're just taking that column. So this is, again, in our original data, we just have different columns. We have a column for life expectancy. We have a column for GDP per capita, and we can do that, and we can put that on this thing, and it looks very similar. Oops, sorry, that's life expectancy, but this one's GDP per capita, and again we see U.S., Canada, and Mexico all improving over time as expected, and we see kind of U.S. and Canada up here and so on. Okay. So that's GDP per capita. Now, one thing we might want to do is we might want to put, so we have two separate graphs, right? I've got a graph for life expectancy and I have a graph for GDP per capita. And what I might want to do is I might want to like combine them into one plot, or maybe even a faceted plot, okay? And so, like, if I want to plot life expectancy and GDP per capita together, okay, maybe on different facets, the format that we have, where I have a separate column for life expectancy and a separate column for GDP per capita, won't work, because the way ggplot works is it needs all of the values that are like, so if I want to put life expectancy on the y-axis and I want to put GDP per capita on the y-axis, it needs all of those things on the y-axis to be in one column, okay? And right now we have two columns. I've got a column for life expectancy and a column for GDP per capita, okay? So what we need to do is we need to pivot our data to be even longer, okay? So we're gonna tell it to take the columns with the values in life expectancy and GDP per capita and basically stack them into one column, okay? And when we do that, we're going to create, we're going to take those two columns, okay, and basically turn them into two other columns, okay? But one column will now just have all of the values, all the numbers in one column. And then the other column will say this corresponds to GDP per capita and this corresponds to life expectancy, okay? And so we'll have the name of the value and the value itself, okay? And if I do it for the three columns, life expectancy, population, and GDP per capita, then all three of those values will get pivoted into one column, and then the value will have the name will have three things in it, which will be whether it's the life expectancy, GDP, or whatever, okay? So our original data, we had three countries, okay, US, Canada, Mexico, and we had 12 years, right? 1952, 1957 up to 2007. So we had 12 years. So we had a total of 36 rows, okay, 36 rows in the column, a column for life expectancy, a column for GDP per capita, and a column for population. And what I'm going to do is I'm going to pivot those three columns into one column, pivot them longer into one column. So we're going to end up with, because we're combining three values into one column, we're going to end up getting 108 rows. Okay, so we're going to go from 36 rows, and we're pivoting three values into one, so we're going to end up getting 36 times 3, 108 rows. And it's going to look kind of like this. So now I need three values to properly identify a row. I need Canada, the country, the year, and what the value is, okay, to properly identify each row. So we're going to have Canada, 1952 life expectancy, 68.8. Canada, 1952 population is whatever, I don't know what number that is, 14 million, okay? Canada, 1952 GDP per capita, 11,000. Okay, Canada, 1957 life expectancy, 70, so on and so forth, and we have these. So all of the values are now in one column. And then what I want to do is I want to plot this. Okay, And so to plot this, okay, so first I take our Gapminder data, and then I'm going to filter it just to those countries. Then I pivot them longer, and then now I want to plot this. Just to kind of keep my plot simple, I'm only going to plot life expectancy and GDP per capita. So I'm going to just filter the rows, so it keeps only life expectancy and GDP per capita. I'm going to basically eliminate the population rows. I could have kept it, but I'm going to just go ahead and eliminate them. I'm going to filter those out. Okay, so I'm going to put in a filter here. And then I do what I have before. ggplot year is going to be X. Okay, and then on the y-axis, now I want to have a plot. I'm going to put the values. Okay, and the value contains both life expectancy and GDP per capita. Okay. So I'm going to have value put on the y-axis. Country is still going to be color. This part's all the same here. And then I'm going to add one more thing here, and this is called facet wrap. And facet wrap, basically, I'm going to say facet wrap based on the name. So that I have tilde name here. And that's going to basically kind of do a separate plot for life expectancy and a separate plot for GDP per capita, okay? And so when I do this, this is one plot, but I've got two facets here, okay? One facet is for life expectancy, and one facet is for GDP per capita, okay? And I have this for US, Canada, Mexico for GDP per capita, and then I got for life expectancy, US, Canada, Mexico plotted here. But we have a problem, and that is, when you do a facet wrap, the default is that the two plots will share the same y-axis, okay? And we can't plot life expectancy and GDP per capita on the same y-axis, because GDP per capita is in the thousands, right? 40,000, this scale goes from 0 to 40,000. For life expectancy, like the max value is going to be like 80, okay? And so that barely registers on here. So we need to have a separate y-axis for this facet than this one, okay? So what I have to do there is under facet wrap, okay, I'm going to add a couple options here so that it will fix it, okay? The other thing that I also want to fix is I just have GDP per cap and life expectancy as my labels, and these are just taking the direct variable names, which I guess is fine, but we might want to have like better names, okay, like prettier ones. And so to do something like that, we can create something called a labeler, okay? And so to have separate y scales, okay, within the facet wrap function, we can use this argument scales equals free, okay? And there's also free y, so free will free both the x and the y-axis, and here the x-axis is year 1950 to 2007 for both, so it doesn't really matter. But if you wanted to keep the x not free, but only the y free, you would use free underscore y, and then vice versa, you can also do free underscore x, okay? And so with that, we tell ggplot to let each facet determine its own y-axis based on the data within that panel. And so then we'll have an appropriate range for the life expectancy going from around 40 to 80, and then we'll have an appropriate range for GDP per capita in the thousands, and that will make it easier, okay? And then to change the labels here, we're going to create something called a labeler, and I'll show you that. That's shown up here as labeler. So this is going to be the code here. So the labelers, so we have as labeler, and basically I just say, hey, this is the original kind of label that we got, and I want to change it to this easier to read label, GDP per capita, and life expect. This will be the label, life expectancy in years, okay? And again, these are just arbitrary, whatever you want to call it, but this will just kind of make it a little bit easier. This part is all the same. Filter to the countries we want. pivot the data longer, filter just to the variables we want. Okay, then we pipe that into ggplot. And then this is just a little thing to keep in mind, is that while you're piping operations, you use the pipe. And then once you start doing ggplot, you're adding plot elements. Okay, you're not piping plot elements into each other. You are adding plot elements. So we change from the pipe operator to the plus operator. Okay, so we want to have lines and points. So we add the theme, and then we're going to add the facet wrap. And then this is where I add the arguments. Scales is free, and the labeler is going to use the labels that we have. And then, ta-da, this is our picture. This is one single plot, and this has GDP per capita over here, and it has life expectancy in years over here. And they are appropriately scaled, and we can kind of see this two plots together, which I think is, I think is nice. So that's what we have. All right, let me give you your first view quiz answer, which is the letter C. C as in cat is our first view quiz answer. Okay. All right, is that okay? So far, so good. All right, so these are a couple examples from the textbook that show again pivoting in action. And so sometimes you're in a situation where data comes in one form, and you want to rearrange it in other ways, and so here's kind of an interesting thing. So here we have two groups, Group A and Group B, and we have sex, F and M. And then for, we took measurements on the left and on the right or something like that, okay? And we got the mean, and we have the standard deviation, and we have all of these things measured, okay? And perhaps, this is the data here, but perhaps we want to arrange them like this, okay? So we kind of want to take our data and make it wide, okay? And basically we want one row for Group A and one row for Group B. And then our columns is we're going to have female mean left, female mean right, female standard deviation left, standard deviation right, and then male mean L and male mean R, and M SDL and M SDR or something like that, right? So we're basically just taking these values and we're just rearranging them as such, okay? And how would we do this, okay? And our textbook gives us a hint. It says use pivot longer along with pivot wider. And so, the desired format that we want is wider, but what we're actually going to do is we're going to pivot it longer first, okay? And so this is just our original data. And it feels a little bit strange, but we're going to first pivot these four columns into one, okay? We're going to take mean L in SDL, mean R in SDR, and we're going to just pivot them longer here, okay? So even though our final goal is a wider table, this intermediate step, by having it in between, we're going to kind of turn all of these things into these, key value pairs, right? And so we get the data in long form, and so our 16 values, we get 16 rows here. And then so this allows me to now kind of, I can pivot this wider into the form that I want, okay? But there's a couple things here. So first, what we need to do is we need to create a column for what the new column headings are going to be. So my column headings over here, we're going to have, we want to call them, f.mean L, f.mean R, and so on and so forth. So we have a very basic text operation, which just says paste, okay? paste the character from one column with another column. Okay? So here, I'm going to create a new column, and we're going to call this the variable name. And I'm going to say take the character from the sex column, paste it with a dot, and take the characters from the name column. Okay? And so we call this concatenating, but basically we're just kind of gluing these elements together. So f and mean L becomes f dot mean L and f dot SDL and stuff. So you could choose whatever character you want. You can have an underscore, you can have a dash, whatever. Okay, so this will create our variable name. Okay, so now I want to pivot this wider again, okay? So I want to have basically a row for A, group A, and a row for group B. And basically the column names are now stored in variable name, and my values are stored in value, okay? So I can say, all right, so we've pivoted it longer, we've mutated our table by adding, we've mutated a new variable, okay? Adding this column here. And then I can say pivot wider, okay? But this is not the correct result, okay? I still have 16 rows, right? So I went from 16 rows and five columns, and what I want is I want two rows and what is this, 9 columns? Okay, that's what I want. And when I did it though, I end up still keeping 16 rows and now 11 columns, okay? And the problem here is that I still have these columns here, okay? I have a column for sex and a column for name. And so the columns, sex and name, they're still present. And so along with the group, okay, I have basically any columns I don't pivot, okay, will be preserved, right? So I'm pivoting the column's value and variable name, but all of these columns will be preserved. And so everything else gets preserved, and there is no, like, all of these rows are unique, okay? I can't combine AF and mean L with AF and SDL, okay? They don't combine. And so all of these things still kind of just remain, and they get preserved, and this is what happens. So what I need to do is I need to just get rid of these two columns, sex and name, okay? Their information is preserved in variable name, so I'm not losing anything by doing that. So here, after creating that new column for a variable name, okay, I'm now only going to keep these 3 columns. I'm going to keep group, variable name, and value, okay? And so now I still have 16 rows and 3 columns now, and when I pivot variable name and value, okay, the only column left is going to be the group column, okay? And then that can get successfully collapsed into one because we don't have separate things now. So then when I take this thing and I pivot, okay, now I get what I want, okay? Does that kind of make sense why this one wasn't pivoted correctly? Because we still have these columns. And when you pivot wider, it takes the columns that you're pivoting, and then the ones that you're not pivoting, it tries to combine them. Okay? It tries to combine them. But all of these things, we can't combine them because each set is unique. Okay? So here, after getting rid of those things, these are the columns I am pivoting. The ones I'm not pivoting, it tries to combine. And here it can successfully combine these because we just have A's. Okay? So they get pivoted. And this is the correct form that we want. All right. Okay, let me give you second answer, which is D. D as in dog. All right. Okay, and then one more example of kind of pivoting. And so sometimes you have data kind of like this, and you want to like calculate differences and stuff like that, right? So here, this is a fictional data set. We've got ID1, and they had their treatment and their numbers, ID2 and their treatment, and ID3 and treatment. And then they also had conditions under control, and we want to calculate the difference between treatment and control, okay? All right, so this is how we have. And so, we can do what we call the naive approach, and we can just say, all right, let me just filter, okay, where just the group is treatment, okay, and then so I get 4, 6, and 8. And then let me also just do it for where we have control, and we get 5, 6, 10. Okay, so I can just say treatment and control, and then let's take the values in control and subtract off the treatment, okay? And this works. I can do 4 minus 5, okay, and 6 minus 6, and 8 minus 10. This works because both sets of data are in the correct order, right? This is in 1, 2, 3, and 1, 2, 3. And so I can do 4 minus 5, 6 minus 6, and 8 minus 10. And I get the correct values of minus 1, 0, and minus 2 because they're both in the order 1, 2, 3. Yeah?
What is a dollar sign here?
The dollar sign is a way to select the column, okay? So there's a couple ways to do it. I think this is on one of the earlier lectures of like when you're dealing with your data, to extract out a column of values. There's a few ways you can do it. One, so because if you use select, you get a table, okay? And if you want to just deal with the vector, there's a couple ways you can do it. One is you use the dollar sign and the name of the column, and that will just give you the vector values. Another is you can use double square brackets and like the column number. So you can do double square brackets. I want in this case, it would be the third column. So you can do double square brackets 3. And then the last is you can do select and pull. So you can say, I want to select the values column and I want to pull those values. So there's 3 ways you can do it. The simplest, in my opinion, is dollar sign. And we're just saying, I just want to get the values in this. Okay, so we're going to do dollar sign vals.
Yeah, in this case, we're pulling 5, 6, and 10.
Yeah, so, all right, so I didn't show the intermediate tables, but here I have a table called treatment, and it's just going to be these first 3 rows. And then here I'm filtering it to just group as control, and that's going to just be these 3 rows, okay? And then, so this is basically my table called control, and I'm going to do control dollar sign values, and that's just going to be this column, 5, 6, 10, right? And so here I have the column 4, 6, 8, the column 5, 6, or the vector 4, 6, 8, and the vector 5, 6, 10. And because they are aligned, I can subtract them. I can just do, and it does element-wise operations. It does 4 minus 5, 6 minus 6, 8 minus 10, and we get the numbers minus 1, 0, and minus 2, and that's correct. But that requires this vector, 4, 6, 8, to be in the correct order for ID 1, 2, 3. And it requires this vector 5, 6, 10 to be in the correct order ID 1, 2, 3. Okay, but sometimes when you get your data, you might have treatment and you might have control, or you might have your 2 groups, and they might not necessarily have the exact same ordering of values, right? So one thing could be ordered by last name and then first name, okay? And then the other could be ordered by first name and then last name, right? And then so you're going to have these kind of listings of people, and they might be the same listings of people, but they might be in different order. Or just like something else has changed and the ordering of people is different. So here I'm kind of simulating that. I just swapped rows 2 and 1, okay? So in one table, in the treatment table, the order goes 2, 1, 3, and so the values will be 6, 4, and 8 rather than 4, 6, 8. Okay, so I just kind of rearranged those rows, okay? And then the other is in order 1, 2, 3. And so if I do the same process that I used on the same thing, if I just kind of copy and paste that same code, I get the wrong values, because now when we do ID1, it should be 4 minus 5. Like in the true thing, it should be the values 4 minus 5, but because I have this arranged in 5, 6, 10, and the order is wrong. Okay, so here it gets 4, 6, 8, and then this one the values get put in the wrong order. Okay, so it ends up subtracting 4 from 6 or 6 from 4, and we get the wrong numbers because these two things are in the wrong order. So the things end up so like this row ends up getting matched with this one, and this one gets matched with this one. Like the 6 and the 5 get matched up because they're in the wrong order. So kind of just saying take this column and take that column and subtract the two can lead to problems. Okay, so this is where using something like pivot wider can fix your issue. And so here, because I have the ID and I have the treatment and this, even though this is in the wrong order, if I say pivot wider, okay, if I say take this thing, even though this is 2, 1, 3, and 1, 2, 3, when I pivot wider, it's going to correctly align the values. Okay, and so now I'll have a column for treatment and a column for control. Okay, and so now these are in the correct alignment. Okay, and then I can just calculate a new column called difference using mutate. I'm going to just say take the treatment value, subtract off the control value. Okay, and we'll get, properly we subtract 6 from 6 and 5 from 4 and 10 from 8, and we have that. And then if I want to rearrange it back in correct ID order into 1, 2, 3, it does that. And we keep the correct values. We preserve the correct values of -1 for the difference for ID 1, 0 for the difference in ID 2, and -2 for the difference in ID 3. Okay, so this is correct, and it aligns with our original correct values over here. This required all of our data to be in the correct order, whereas this does not. When we use pivot wider, it can be out of order, but it will still correctly align them. Okay, so I guess that's an important thing to keep in mind if you are going to be calculating, differences between columns or something like that. You want to make sure the numbers do properly align, especially if you're going to try to if you have different sources of data or something. Okay. All right, I guess that's it. We'll finish a little bit early. Last view quiz answer today is the letter A as in apple. Okay, and we'll wrap things up here. Again, meet with your groups, talk about what kind of data sets you want to look for. Go out there and look for some data sets. Next week, I will put up a sign-up sheet to set up an appointment for your proposal meeting, and I'll talk about exactly what I expect during the proposal meeting. So we'll talk about that. Okay, all right. Have a great weekend, and we'll see you Monday or at DataFest.